Now in this video, we're going to be summarizing the past videos we just went over. Now a vector space is considered a collection of vectors. Now for these collection of vectors to be considered a vector space, it must pass a few properties. It has to pass vector space addition. You must make sure that the vectors are commutative. There is a zero vector included, inverses check out, and that there's associativity amongst the collection of vectors. Now with the vector space comes a subspace. A subspace is a space within the vector space that satisfies two criteria as well. There's a common thing going on amongst these two, and you'll see with the rest that they each have their own properties they must pass in order to be considered their term. So back to subspaces, we must be able to add vectors and scale them, and they must still remain within the same vector space. So if we have two vectors and one of them, and when we add them, they come out of the vector space, it would not be considered a subspace. Now, an inner product space is a vector space with an additional structure called an inner product space. In inner product spaces, they also have their properties. They must be able to be multiplied, they must have commutativity, distributivity, factorability, and non-negativity. The inner product of a vector space can be a set of functions expressed as coordinates. An inner product can be used to find the magnitude and norm of a function and distance between two continuous functions in a vector space. Which leads me on now to my linear transformations. Linear transformations also has two properties. It has an additive and scalar property. If transformations pass both those properties, it is considered a linear transformation over that vector space. Now, some of the uses for linear algebra can be considered for machine learning, data analysts, computer programming, vectors and rationalizing, probabilities, but one of the most important things it's going to help me out with is transferring out to a Cal State. Thank you, Professor.